when talking about a system of equations in two variables, we talked about earlier how we can think of the solutions as the intersection point of two lines. However, it's possible that two lines don't intersect. They could be parallel. So let's try to do an example and see what happens in these cases. Let's consider the system 3x plus 5y equal to -7 and 6x plus 10y equal to 8. Since none of my variables have a coefficient of 1, it's going to be best to use the elimination method. I'm going to multiply the first equation by -2, since that would give me a -6x to go with my 6x in the second equation. So my first equation becomes -6x minus 10y is equal to 14, and my second equation stays the same, 6x plus 10y equal to 8. When I try to add these equations together, I can see my x's cancel, and so do my y's. This leaves me with 0 on the left-hand side and 22 on the right. But there's no situation ever where 0 is equal to 22. So we would say that this has no solution. It's never the case where 0 is equal to 22, so there's nothing that we can use for x and y to get both of these equations to hold. So these would be parallel lines. And anytime we're solving a linear system of parallel lines that doesn't have a solution, we'll always get a false statement at some point in the process, such as the 0 equal to 22. So we've now looked at the case where we have parallel lines, and we've considered the case where they intersect exactly once. Is it possible for two lines to intersect more than once? Since we're considering straight lines, there's only one possible way this can happen, if they intersect infinitely many times. Or in other words, if they're the same line, just written two different ways. So let's investigate that situation. This time I have the system x plus 4y equal to -4 and 3x plus 12y equal to -12. So I'm going to multiply the top equation by -3 and leave the second equation alone. When I do that, my top equation becomes -3x minus 12y is equal to 12, and the bottom equation stays the same. When we add these together, we see that everything cancels. And we end up with 0 is equal to 0, which is always true. And this is what's going to happen whenever we have infinite solutions. No solutions will give us a false statement like 0 equal to 22. Infinite solutions will give us a statement that's always true, like 0 equal to 0. However, not every single ordered pair is going to work for this system. So we do want a way to denote which ordered pairs work and which don't. So to do this, we're going to take our line and put it in slope-intercept form. Since we get 0 equal to 0, we know that these are actually the same line, so it doesn't matter which equation we start with. So I'm going to start with the first one. We start by subtracting x from both sides. That gives us 4y is equal to -x minus 4. We then divide through by 4, which gives us y equal to -1/4 x minus 1. So if I can pick any value for x I want, I now have an equation to give me the appropriate value of y. To write this as a solution, we tend to write it as t, comma, -1/4 t minus 1. So this means our x variable we can pick to be whatever we want, and then we can determine our y variable based on this equation.